Welcome to Cloud on Air, our live webinars from Google Cloud. We're hosting webinars every Tuesday, and we're really happy to have you here with us. My name is Yuri Grinstein. I'm a customer engineer here at Google Cloud, and I'm incredibly happy and excited to have Carter Maslin, the founder and CEO of Camio, with us today. Carter, thank you so much for being here.
I'm happy to be here.
Fantastic. You can ask questions anytime on the platform. We'll have Googlers on standby to answer them. We'll also be doing a live Q&A later in the program. So first of all, Carter, again, thank you for being here, and congratulations on your Best of CES award.
Thank you. I was just extremely excited about that.
Great. So today we'll be talking about how you have built Camio to provide machine learning for video intelligence to your customers. So perhaps we should start by you telling us the problem you set out to solve.
Yeah, so Camio is real-time video search that works with any camera stream. And the big problem with video today is that in recording hours and hours of video, there's only a certain small fraction of it that's actually warranting any attention from humans. And so getting machines to do that work for you, to highlight what's interesting, is the core of what Camio is about. So that real-time video search will automatically identify the few 2 minutes perhaps each out of every day that is warranting your attention.
Fantastic. So why don't we have you show us kind of exactly what this looks like in practice?
That'd be good. We'll jump to a demo where I can just do a quick search. And I'll just start by looking at a single camera like Liverpool, which is a public library in New York. And the first thing to notice is that there's no dead air time. So the first level of machine learning is just highlighting interesting events that warrant your attention over a large period of time. But you can do quick searches like this. I can just say I'm looking for people in red or blue on the sidewalk. And now out of a 2 or 3 week period, I'm seeing every time there was a person that was either in red or blue across the sidewalk, including a quick chart for the frequency. You can just see this is all the times that people in blue, all the times people in red, or all the times that there were people, period. And that same thing applies. You can still play the video behind the event, but you can also do advanced searches. Like if I only want to see when there were bikes across all the cameras, you can just type in bikes. And now this is using CNNs to label the events for the cases where there was a bike. And like I said before, you can play even this person that's dedicated in wintertime snow biking. It'll find that. You can also do a quick search for something as advanced as snowplow. So I'll just do a quick search. Snowplow for that same period. And so this is just a quick example. All these demos are things that you can open in your browser and do yourself at camio.com/demo. There's a sequence of links that you can open without any kind of auth and follow along as we do demos throughout this discussion.
Fantastic, thank you. So that looks really cool and really impressive. You're able to very quickly find interesting things in these videos, and the UI is really fast, and it looks like it can provide a lot of value. Can you give us a sense of who might actually use this?
Yeah, so anybody that has cameras, large corporate campuses, cities, even homes are using it. But it's basically the core value of Camio is that it can work with the video streams from old camera systems, existing camera systems, your existing DVR or NVR, and make it into something that's smart and searchable and browsable, so that it learns what you find interesting in each individual camera stream.
Fantastic. All right, so let's go back to our content and resume there. And I think the next thing our audience would very much like to understand is some of the decisions that went into building Camio. And first, why did you choose to build it on GCP?
Well, our founders came from Google, so we were familiar with that at the beginning, but the core reason that we chose GCP was the dynamic scalability and quick deployment time. So we deploy several times a day, and as a startup, your core advantage is just listening to what customers want and delivering it quickly. And to be able to hit the deploy button, several times a day without the hassles of any kind of hardware issues or maintenance issues, that was a big one. But then the core of the problem is just matched to the dynamic scaling. So this chart, I don't know if you can present this chart of a real-life deployment with 62 cameras that shows the number of events over the time of day, and you can see that it's very spiky. It's 5 times the traffic during a daytime shopping mall versus the nighttime, and when you have that kind of a problem where you're saying, well, tell me what's interesting out of hours of video with this kind of spiky activity level, having the dynamic provisioning automatically scale your compute resources to match what you're analyzing is a key strength. So rather than having to deal with on-site, on-premise hardware that has to be provisioned at peak capacity, you can instead provision at a much lower dynamic rate that's much more cost efficient and much more bandwidth efficient.
Mm-hmm. Yeah, I think you make a really important point here is that it would be really difficult to achieve optimization using any kind of a traditional on-premise infrastructure with a workload and a demand that looks like this. I mean, this is incredibly spiky, right? Like you said, I think your delta between your baseline here and your peak it looks to be at least 5x, if not more.
Right. I mean, you have some cameras that might be like a mechanical room or a server room where credit card data is processed, where there's very low activity. And then you've got others that are like the main entrance for a shopping mall, and so it's not just hour of day, but it's by kind of the venue of the camera. And so making that cost efficient is the core focus is, how do you take the mass of millions of existing cameras and connect them to state-of-the-art machine learning at a price point that makes sense for people on a business perspective?
Yeah, absolutely. Makes a lot of sense. All right, so this looks really interesting. Let's move on to kind of how this actually works. So it looks like there's really 4 major components to Camio, right? There's the customer's on-premise infrastructure, which is what they need to collect the video and send it to the cloud for processing. There's all the stuff that happens in the cloud. There's the user experience, which is delivered via web and native mobile apps. And then the hook as well, which we'll cover a bit later on. So let's first start by talking about what does the customer of yours need to really do this? Let's start with the cameras. I think you said this already, that they can use their existing cameras as well as new ones, but are these special purpose cameras or can they just be any camera?
They can literally be any camera. The nice thing is that Camio analyzes the H.264 video stream itself that comes from the camera directly or from a network video recorder like a DVR or a video management system, a VMS. And so no matter where it comes from, your existing cameras, even analog cameras that are connected through one of those NVRs can be accessed via Camio. So in terms of a customer's deployment, they can light up their existing cameras in less than 10 minutes because as long as the cameras are on a network, that's all that's needed.
Fantastic. So then the second part of their on-premise infrastructure would be the network video recorders or video management systems. So one, is that a required component? And two, how does that system really play into this?
So the network video recorder, or VMS, is usually used to provide the complete archive of HD video on-site, on-premise. So you can either use that or go direct to the cloud. You can choose. So it becomes mainly an issue of like, what's your uplink bandwidth? What are your archive and retention requirements and things? But you're free to serve the video streams from the NVR or from the camera. It doesn't matter which.
Very cool. And then the third part of their on-premise deployment is this thing that's just called Box. Yes. Well, that sounds awfully mysterious. Can you tell us a bit about what the Box is?
Yes, the Box is a video gateway. It's basically a device that analyzes the video streams on the local network. So you get a huge bandwidth efficiency gain because all of the analysis and metadata that's observed about each 12-second video event is analyzed locally by the Box. And the Box is in this kind of chatty conversation with the cloud saying, hey, do you find this interesting? Based on what you've seen the user do you think the user wants this? And all of those decisions in that chatty conversation are determining what happens subsequently in analyzing the video. And that's where the big cost efficiencies come from because, you saw the spikes. And if a camera's, even with high activity, if only a fraction of it is interesting, like when a person approaches the server room that houses your credit card data. That's when you want HD recording with full analysis and integration with your security operations center and things. So all of those kinds of decisions are made locally by the machine learning that's running on Box. And we'll talk about later what machine learning on Box does, but the second thing that Box does is gives you security. So you remember the Mirai virus?
I do.
Yeah, so that was a massive attack that was using people's cameras and DVRs, the vulnerability in them, because the traditional deployment model for cameras on corporate campuses and things for when you need remote viewing was to forward inbound ports. And since Box is only over SSL, port 443, you can completely close your local network to inbound network requests.
Yeah.
So in addition to its efficiency function, there's also a really good security function because you can now close all inbound ports on your local networks to avoid a repeat of the Mirai virus.
Fantastic. All right, so we've got our cameras. They're capturing all this video. We have our NVR or VMS that's archiving all the HD video. And we have the Box that's basically kind of efficiently choosing which bits to actually send to the cloud for processing. So which takes us to the part that I think most folks online are here to actually see, which is what are you doing in the cloud?
Yes.
So let's move into that. Let's kind of cover three major paths that I think are going to be interesting to our audience. First is kind of what you're doing with the video when it arrives. The second one will be kind of how you're delivering that user experience, right? You showed us the UI, it's incredibly fast, it's really responsive, and it's operating on, obviously, what are fairly complex data sets. So I'd love to hear about how you're really making that as performant as it is. And then thirdly, we'll talk about how you're taking both the video's data as well as the user interaction data and combining them to power your ML. Does that sound good?
That sounds good.
All right, so let's talk about the video first. You've got your cameras, you've got your Box. Box sends video to the cloud. What happens then?
So as I mentioned, there's a front end that's basically in the chatty conversation with the Box. And so we use App Engine Standard as that front end for the dynamic scaling and responsiveness to both APIs queries and end user search API queries. And so that is the initial entry point, is the Google front end that's talking to an App Engine Standard set of instances. And then those decisions made at the beginning based on the trained models to that point determine all the subsequent workflow that you see on the right side of this chart. So what level of analysis should be applied to this? Where should the storage go? So if you want to just have a response that says, hey, for this video, send it to nearline storage because it's unlikely to be reviewed. So for cost efficiency, just let me give you a signed GCS URL and just send it straight to GCS versus this is an important event, so let's call hooks that are things like the Google Vision API or other specialized classifiers because this is particularly important. All of that workflow is determined after it goes through the front end with these dynamically provisioned App Engine Standard instances.
Yeah, and it makes a lot of sense that you're using App Engine Standard because of the kind of the big spikiness that you have in your traffic, right? That's sort of a textbook use case for App Engine, right? When you have sort of very unpredictable workloads, very spiky workloads, App Engine can scale as high as it needs to. It can scale down as low as it needs to, all the way to zero. Although obviously with camera sources, you probably never quite at zero, but it certainly makes a lot of sense that you're using App Engine that way.
Yeah, I mean, for the people that are opening the demo page, cameo.com/demo, your queries are spinning up instances in response to your individual queries because there's a mismatch out of the workload for recording and analyzing video versus querying video because you do much less querying. So there's also the dynamic provisioning based on you guys going to the website right now and doing your own searches. Those are spinning up instances to make sure you get good response times.
Fantastic. All right, so that kind of helps us understand what you're doing with the video as it comes to the platform. Now let's talk about all those users out there that are, again, going to cameo.com/demo and actually trying this stuff for themselves. How are you delivering that experience?
So there's a front-end query parser that kind of determines, based on what's observed in your camera feeds, what you're asking for. So when you do a search like, Toyota Prius yesterday 1 p.m., it's parsing that and it knows that Toyota Prius is a make and model of a car that you're looking for in your feed. So the first step is just understanding your query, and that language has some natural language processing of the query itself, so you can say, 1 day ago at noon. And also terms and labels that are applicable to your cameras. And that's all served from data store. So data store is indexed based on both the time, the camera source, the user, all that stuff to make it fast and searchable. And the video itself is served from Google Cloud Storage. And in the process of taking in video, there's a whole bunch of workflows that are triggered from both Cloud Data Flow and just task queues and pub sub that are triggered based on the content of the video.
Okay. So that's actually, I think, an interesting point. Can you tell us a little bit about kind of how you're using App Engine task queues and data flow, and kind of what are the two things that you're achieving with those?
I guess on the task queue front, the big value that we actually didn't anticipate when we first started using task queues was just how resilient it is. And we've learned some, in terms of like if you have a temporary mem cache failure or a temporary data store failure, it's seamless to the users. There's no impact because it gets retried, and it's a really nice mechanism to have communication among modules and versions of your app. So in our case, our application is split with a lot in Python and a lot of the front end in Java. We have modules that have different kinds of workloads, and task queues are an easy way to coordinate functions among them reliably without kind of any risk of loss of data or loss of the request. The same thing with PubSub. We'll use PubSub for simple things like if a batch operation is completed, somebody might have created a time lapse, let's say. So they may have said, give me a time lapse of my camera from 8 a.m. Monday to 5 p.m. Friday on a construction site. When that's completed, we'll use PubSub just to notify people of the completion, including our internal processes that'll do the billing and stuff. So it's just been a really good, flexible mechanism to coordinate communication across all the different modules and application versions.
So you're using task queues to kind of do some of that orchestration between modules. You're using PubSub to do some of that communication, and things like notifications are sent using PubSub. What's the role of data flow in this architecture?
We're mainly using the mappers for data flow, not so much the reducing, but we do periodic summaries of counters because Camio is all based on usage-based billing. So data flow helps us go over massive amounts of events. I mean, each camera, each day there's millions of events to be summarized on how many megabytes have been uploaded, how many important events, how many unimportant events. All of those things are done via data flow, including the triggers to manage billing cycles and things that are driven off of those counters.
Fantastic. All right, so now we've covered kind of what you're doing with the video as it comes in from the camera through the box and is ingested. We've covered kind of what you're doing to provide that user experience in the UI. Tell me how you're combining those two data sources to actually do machine learning in the platform.
Yeah, that's the key thing, is that the neural nets that are being trained are on a camera-specific basis. So, on the box itself, there's something that we call internally adaptive motion filtering, which is a set of neural nets that are all concurrently competing to be right about what's interesting for that particular camera. And the tricky thing in cameras is that it's not just about eliminating spurious pixel motion, because there are a lot of times where a scene has something that is a real object moving, but it's just not interesting. Like you could have in the front of a commercial building entrance a tree that has just a blowing branch that is just swaying periodically. It is a real object moving, but it's not interesting. And so the box itself has neural nets that are learning that swaying branch is not interesting. But then the feedback loops that come from you using the product. So when you play an event, or you share an event, or you save an event, or you give it an explicit thumbs up or thumbs down, kind of like you're rating songs, those all are now collected training feedback for your individual camera. So even though there's no visibility into what your camera is actually observing, it still can train itself based on the way that you use the product. And so those things surface in the clean summary of your video and kind of the precision of the search results, but also in some efficiency things. So I was going to show one example of that efficiency part of the machine learning.
Yeah, let's do that. So we'll do one more demo.
This is a demo that we call the matrix demo. And part of the machine learning is identifying what is interesting versus not interesting. And in this case, there's a lot of passing street traffic that'll be in low res, fast time lapse. And then when the person that's approaching the sidewalk, which is the nighttime library that you want to actually observe, it'll slow down into full HD recording. So this is why we call it the matrix effect, because you'll see the passing street traffic is low res, fast time lapse, and then it slows down to HD right as the person comes into view. So we love that as an example of machine learning that is smart enough to differentiate between passing street traffic and the people that you're actually trying to protect at night at the library.
Yeah, and that's actually really amazing. Not only does it know that hey, something is happening that's different than what was happening before, it's something that might be interesting. I now need to provide additional context around that, and like you said, right, give you that kind of full frame, high definition feed now, so someone who's kind of looking at this video after the fact can actually, make decisions around what did they see? Is it something that they need to take action on?
And just from an economics perspective, you're saving both bandwidth and storage and processing costs by kind of, this was when we first started talking, we were talking about the power efficiency of having machine learning make decisions on what compute resources are applied to any particular video event. And it's not dissimilar from some of the things that I've read on the machine learning that did a better job managing power in Google data centers than humans. And so it's similar for your video feeds, where we're actually having the machines help you save bandwidth and compute costs by knowing what warrants the extra work.
Yep, fantastic. All right, so now that we've seen the demo, let's get back to our content here. And the next question I have is, now that we sort of understand kind of what you're doing with the data in GCP, and we understand some of the use cases that are sort of there, quote unquote, out of the box, although not the Camio box. I imagine that you have lots of customers that come to you and ask you to do things that the platform has not been built to do. How do you support kind of new use cases, new classifiers, and new requirements?
That was one of the key design criteria for Camio, is that we wanted it to be a video processing pipeline that's open on both ends. So not only is it open to all cameras, but it's open to all machine learning classifiers and third-party hooks. So hooks are the way that Camio has an extensible pipeline, and it's been used for things as funny as, like, we had no classifier for fish faces, and there was a Kaggle competition to classify yellowfin tuna versus bluefin tuna versus marlin and sharks, and it's as simple as defining a hook in the Camio pipeline where you can say, when the fish door opens or when there's a human on deck, I want you to run additional classifiers that are smart enough to differentiate between types of fish. And that's not an expertise we have, but in the old adage, there's more smart people outside of your company than in your company. That's the reason that we have hooks, is that now all that grunge work of getting millions of cameras connected and being able to be processed are now accessible to third parties that may specialize in face recognition, whether they're fish faces or other, or access control systems that want to be integrated. All of this is an extensible thing. So you just register a hook and do the additional analysis that you'd like to do.
Fantastic. So hooks are a great way for folks to take advantage of the pipeline that you've built to do, like you said, classification that isn't there out of the box.
Yeah, I mean, in this example, this was not even additional classification. If you look at this command, it's basically, we'll just do a quick walkthrough. You're saying, when there's a match on this query, it's much like if you've used Google Alerts, search alerts.
Absolutely.
It's the same thing in Camio. When you pin a query, that now becomes an alert. That's the same thing that drives the API for hooks. You basically say, whenever there's people 2 a.m. to 5 a.m. on the rooftop, this is an example of a query, do this, which in this case was a request to have a callback URL that would just schedule a guard on-premise guard tour. So now, instead of just having your on-site security staff roam, you're getting targeted alerts based on query matches. So this curl command, it's a single simple command that just says when that query match happens, call me back, giving me the payload of which camera source observed it, what the earliest and latest time was, and what we labeled it with. And now that can drive your scheduling system for a guard tour. It can drive your notification systems. It can do anything. So this is the flexibility in extending via hooks.
Fantastic. So hooks are a great way to kind of get additional information that may not be there out of the box. How would you go about understanding like when things are happening? So in your example, right, I know that I saw people on the rooftop kind of between the specific hours, but what if I want to know exactly when someone opened that hatch, for example, and started climbing out? How do I go about doing that?
So maybe we could look at annotations quickly. This is an example where part of the pipeline enables you to correlate any label to a timestamp. And that means that any device, whether it's a door sensor or an access control badge in, can now be a source of annotating a video feed. So if you want to say, show me every time that the fish door was opened, it's simple to see that in video because this one command just says, put these labels, badge 123 unlocked as a door unlock event. Now, whenever you search for show me the times that this door was unlocked, you'll see the video that matches those events that come from those sensors. So it's not just about the video content, but it's also third-party devices and sensors that can be integrated into that video content.
Fantastic. So now we've covered kind of hooks and annotations, which are ways by which other people can, again, take advantage of the platform and the pipeline you've built. Thank you so much for that. Before we get into the Q&A, I wanted to ask you one last question. Kind of as you've built out your infrastructure and your platform on GCP, are there any lessons that you've learned that you think our audience would benefit from?
Yeah, I mean, I think if I were to summarize kind of some of the top lessons from the past years of working with GCP, one of the first ones is in terms of your data, if you're using data store, make sure you think in terms of key value buckets. Because if you come from a relational background, you may be tempted to just take your relational thinking into a data store. And if you want to avoid problems with eventual consistency and indexing update times and things like that, think of your data as atomic key value buckets rather than as rows in a relational table. That's probably one.
Yeah, makes sense.
Two, in terms of performance, we found that almost always when you profile your application for performance, RPCs, remote procedure calls, are the culprit. So think about how you do things in parallel. So if you have like a list of events that you're going to display on the screen, like you're seeing with our search results, do a batch get, so that you've got a list of 60 keys that you're fetching in one RPC that it can all be in parallel rather than doing that sequentially. So that's another lesson. I'm trying to think of other highlights that we've learned. But those are two starting points.
Yeah, no, those are very good. And on that second point, I'll make a bit of a product pitch, which is, folks, if you're interested in understanding the performance of the RPCs in your application, take a look at the trace functionality within Stackdriver. It can really expose those slow-running RPCs and tell you exactly where some of the latency in your application calls may be. Well, awesome. Thank you so much. I think now we will take a quick break. Please stay tuned for the live Q&A, and we'll be back in less than 1 minute. Welcome back. Let's go through some of the questions that you have for us. Our first question is, how does Camio charge its customers given how much heavy processing you're doing?
That's a great question. We at one point had started with like a fixed monthly price, and we realized quickly that the workloads vary so much by what the camera is observing. So you could have a really inexpensive camera in a quiet server room with credit card processing data and a really busy camera observing a parking garage. And so we have usage-based pricing. So you can pay on a per gigabyte basis, and that enables you to tune the machine learning. We also wanted to have that incentive where as it gets smarter, your prices go down. And so basically Camio has custom plans that our partners offer that are all tuned to your specific video processing needs, including duration of storage. Do you need 90-day storage, a year storage? What kinds of advanced analytics do you want? Do you want car classification or just OCR text recognition? What amount of events do you want processed every day? All of these things are variables that go into the pricing of a plan so that you get the lowest possible price for your workload.
Great, so it sounds like kind of the two real metrics are going to be how much video you're processing, and then the second part is kind of how complex the processing is.
Yep.
Okay, great.
Yep.
All right, so next question is, if I see something interesting happen in the feed, how do I go about sharing the video to the world? And is this kind of the same as traditional video sharing, or are you doing something different there?
It's different in the sense that our share via links, we call them query links. When you share a link, it's like sharing a constrained view onto a feed that you can revoke at any time. So for everybody that's used Google Doc sharing, you have an option where you can either add somebody as a permanent collaborator, or you can just send a link. And so we have that same model. You can either send a link so that when you're doing these demos on the camio.com demo page, that's an example of query links because they give you the right to access the content just by having the token that is in that query. But if you have somebody that is part of your security operations staff, for example, they may be a permanent guest on the account, much like a collaborator on a document. But the difference in Camio's case is that the sharing can be constrained to specific segments. So it's like if you could share a Google Doc, but only one paragraph of the document. And I'll give an example of that. If I could do a demo from a city camera here. This is an example of a city camera that is the last demo link on the demo page. And this is only 9:45 to 10 a.m. on last Friday. Okay. And so the interesting thing is if I try to scroll earlier, it stops at 9:45, even though there's a lot of other video. So this is the example of sharing a paragraph within a doc. But the interesting thing is I can still search within that query link that's shared with me. So if I want to do this search, I'll just say what I was really looking for is a white Toyota. Now, let me just see if there was no white Toyota at that point. So I'll just look for a white car. And now I'm subsetting my search to just be the events that had a white car in them. And so you can do the same thing with a constrained period of time where I can say I was just looking for 9:50 a.m. to 9:52 a.m. On Friday. And now, because that is within the constraints of the 9:45 to 10 sharing, I can still do this. So if you take a scenario like the Boston Marathon bombing, where they had 1,000 people review video for 3 days to find the suspects, this kind of crowdsourced review gives you a secure way to share a very limited portion of your video stream, but enables people to do search refinements and additional queries within the constraints of what you shared. And you can add, you can share by link, but you can also add people to the link so that they still have to authenticate. So that's the other level of sharing is even when you share via link, you can still additionally require that somebody be authenticated.
Yep. So it sounds like you have some very powerful sharing capabilities, both in allowing other folks to view and collaborate in the streams, but also control kind of what they can actually see to control their access to perhaps specific slices of time.
Yeah, or zones. Like you could say
searches.
if they can only see people that are coming out of an elevator, you could have a zone elevator share only that zone, and then they can't see what's happening over in another office room. It would only be the events that are intersecting with the elevator.
Yeah, fantastic. And I think that also answers our next question about granularity of access. I think you've done a great job of covering that. So our final question is actually around the box, believe it or not. So you're using a gateway on site to do pre-processing and then sending it to the cloud. How many kind of parallel streams can this gateway actually manage? Or maybe a broader question is, how do you go about deploying a system by which there are many cameras?
So the simple answer is I could just give you the rough metrics. It's because it's dependent on the streams that are being monitored. So if you have 4K streams at 30 frames per second versus 720p streams at 20 frames per second, that's a big difference.
Sure.
But the general point is that it scales based on the number of streams and the characteristics of the stream. So to give an example, just if you just have 3 HD 1080p streams at 30 frames per second, you can use a tiny little box that will handle those 3. And then if you go to 6, you can just linearly stack more boxes.
Okay.
But you can also run Box as a virtual machine on any set of servers. So if you have 120 cameras on campus, you can run that on a single server if it's beefy enough.
Understood.
So we have tools that estimate, you enter in the characteristics of your stream, like I have 1080p streams at 30 frames per second at this 4 megabit encoding rate, and then it spits out your recommended number of boxes based on the number of CPUs and number of memory and stuff. So I hate to say it depends, but it really does depend. We're trying to make it simple by using a spreadsheet that is on our site that will give you an answer to this question. There's a help article on how do I scale to the number of streams that I'm monitoring.
Fantastic. All right, that's all the questions we had. Carter, thank you so much for being here. Really appreciate it. Folks on the stream, thank you so much for tuning in. We sincerely hope you have found this useful and informative. I think it was a great way to kind of showcase some of the really cool capabilities of GCP, things like auto-scaling and the ability to kind of ingest these massive amounts of data and do some machine learning processing on them. Before we sign off, I want to let you know that if you've enjoyed this format, you should tune in to a less formal session that we run once or twice a week. It's called the GCP Online Meetup. You can find us on meetup.com or subscribe to us on YouTube at youtube.com/GCPlive. We'll be signing off, but please stay tuned for the next session called Accelerating Your Google Cloud Migration, which will be coming to you live from the Google New York office shortly. Thank you and have a great day.